Hello, I'm a science teacher and today I'm going to do a tiny little 5-minute slot all about density. But before I start, I've got a very quick question for you. What would weigh more, a box containing a kilogram of gold or a box containing a kilogram of candy floss? Don't give me an answer straight away, have a little think, have a little pause. You thought? They are both 1 kilogram. So the box of gold and the box of candy floss would weigh exactly the same. But how big a box would you need to have a kilogram of gold? It's only a guess, but I'd say a box a bit like this. And how big would you need a box to hold a kilogram of candy floss? Again, I'm only guessing, but I'd say it'd be much more like this. So what's the difference? Why do we need such radically different sized boxes to hold a kilogram of gold and of candy floss? It's a very, very simple answer, all contained in one word, and that's density. They have a very different density. So what does density mean? Density sort of explains how much stuff is packed into a particular space, like a box. And when I say stuff, it's not any old stuff, it's molecules. A molecule is the very, very smallest unit anything can be broken down into without changing that thing into a different thing. Now, when we look at gold, every molecule of gold has more than 100 atoms in it, and the molecules are all packed together, each 100 bunch, very, very, very tightly. Candy floss, which is just pure sugar, has only 45 atoms in each of its molecules, and each one of those molecules aren't packed nearly as tightly with each other, so it's less dense. Look at my diagram and you will see exactly what I mean. Sugar molecules have a density less than 2 grams per centimetre cubed, whilst gold, with its molecules all crammed in together, has a much greater density of around 19 grams per centimetre cubed. When I'm doing all this stuff about density, it's not just solids like gold that it applies to. You can apply it to anything. You can apply it to gases like the air and to liquids. And once we start to know the densities different things have, we can start to do some really fun experiments. And today I've got two I'd like to show you. Here, I've got a little beaker of water. I put some green food colouring in just so you can actually see the water in the glass. And here, I've got some regular old standard cooking oil. But do they have the same density? Are the densities different? And what will happen if I pour the oil into the water? While I pour the oil in, you have a little think and predict what will happen. Will they mix all together? Will one sit on top of the other one? How will it sit if it does? Here we go. You can see it, it's going in. And there. The oil has a density less than the density of the water, and so it sits on top of the water. You can try that at home and with many other different liquids. But here's a slightly different one. Here, I've got some pink lemonade. That looks nice, quite tasty. And here I've got some fruit juice. Will this be like the oil, or will it be different? While I pour it, you make a prediction. Completely mixed in, and that's because, though not exactly the same, the density of the lemonade and of the fruit juice are very similar. But now, this is the magic bit. I've got some grenadine, it's just a fruity syrup. What will happen when I pour the grenadine into my fruity lemonade-y mix? You making your predictions? You know where it's going to land? And as well as predicting, give me a reason why you've predicted what you have. This one is quite the opposite. Having a larger, a greater density, the fruit syrup has sunk right to the bottom. Makes for a rather exotic looking drink, a rather beautiful drink that tastes equally as lovely. Cheers. See you again next time.